Hello everyone, we are now in quarter 1, module 3, lesson 2, standard equation of an ellipse whose center is at the origin. We have here the objective. Find the standard equation of an ellipse whose center is at the origin. Okay, so we have here the concept notes. Standard equation of an ellipse whose center is at the origin. Let C is less than A but greater than 0, and B is equal to the square root of A squared minus C squared, an equation of the ellipse whose center at the origin and with foci at F1 negative C0 and F2 positive C0, and vertices at V1 negative A0 and V2 positive A0 is x squared over a squared plus y squared over b squared is equal to 1. Okay. If the foci at f1 equals 0 negative c and f2 0 positive c, okay, so we have here the vertices at v1 0 negative a and v2 0 positive a. The equation is x squared over b squared plus y squared over a squared is equal to 1. Okay, so we have here the figure. In the first figure, if you can see here, okay, so the major axis is horizontal. So if you look at this one, this is the major axis. Okay, so the major axis is horizontal and the minor, this one, is the W1 and W2, that is called the minor axis, which is the vertical. Okay, in figure number 2, we have here the major axis, the vertex 1 and vertex 2. If you look at the given, okay, so the vertex 1 and vertex 2 is called the major axis. And W1 and W2, that is the minor axis, which is the horizontal. For the first figure, the given equation here, since this is the major axis is horizontal, so the given equation is x squared over a squared plus y squared over b squared equals 1. Where in the second figure, the major axis is vertical. Okay, since that is vertical, so the given equation is x squared over b squared plus y squared over a squared is equal to 1. Okay, so we have here the example. Find an equation of the ellipse whose center is at the origin and with foci at plus minus 5, 0. It means that the focus or the f1 is negative 5, 0, and the coordinate of focus 2 is positive 5, 0, and vertices at plus minus 7, 0. Okay, so we have here the solution. Since there are two standard equations of an ellipse based on the given, it falls under the first case. Okay, so if you look at the given, the foci and the vertices, and you are going to locate that one into the Cartesian coordinate plane, so this figure is falls under the case 1, which the major axis is on the horizontal. Okay, so first case, given here the value of c, remember that focus, the coordinate of focus is plus minus c0, so the value of c is 5, and the vertices are plus minus a0, so the value of a is 7. Okay, since you have already the value of c, which is 5, a is 7, you are going to find now the value of b using the formula. Okay, so the formula to find the value of b is equal to the square root of a squared minus c squared. Okay, you are going to substitute the given value. So the value of a is 7, so 7 squared minus 5 squared. We have here the square root of 7 times 7, that is 49, minus 5 times 5 is 25. So b is equal to the square root of 29 minus 25. The result is the square root of 24. Okay, solving for the equation of an ellipse. Remember that we are going to use the formula of x squared over a squared plus y squared over b squared is equal to 1. Since the center is 0, 0 and the value of a is 7 and b based on the computation that we have, that is b is equal to the square root of 24. Then we are going to substitute to the given equation. Okay, so we have here x squared over the value of a, which is 7 squared, plus y squared over the square root of 24 squared is equal to 1. Okay, then after that, we are going to simplify. We have here x squared over 7 times 7, that is 49, plus y squared over the square root of 24 squared. You can cancel the radical and the exponents. The remaining value is only 24. So we have here x squared over 49 plus y squared over 24 is equal to 1. That is now the equation of an ellipse. Okay, so watch more. Find the equation of an ellipse whose center is at the origin. Okay, you are given two exercises to find the answer or to solve the equation of an ellipse. Okay, thank you for listening and do not forget to click the bell icon to subscribe my channel.